Okay, so in section 7.5, we're going to talk about a theorem, a couple theorems here, in order to find zeros of a polynomial function. So we'll see we're going to use this thing called a complex conjugate theorem. So what that means is when we have complex solutions, we're expected to see something happen. We'll discuss that, but first, and then second, we're going to talk about this thing called the fundamental theorem of algebra to a certain extent. And we're going to use this idea to create functions like we did with the check yourself video at the first part of this section. So first with though is another review, and this is important because there's a lot of different things that we've been doing in this chapter. So what I want you to do is pause the video just like with the checkup and do the problem and then match to confirm that you've found the solution. So we have a cubic equation here, and I know some basic details about this regarding solutions. So there's multiple methods. We've solved using graphing, synthetic division, and factoring. So some things are more efficient than others, and so what I'm going to do is when I come back to the video after you've tried to solve the problem, is I'm going to talk about what methods I might try first, and then that tells me what I have to go to in order to solve the problem. So the first thing I tried is factoring, and I did factoring by grouping because I saw four terms here, so I split the middle and I pulled the greatest common factor out of each side, but notice it doesn't match, so I can't factor. So what I'm actually going to have to do here is I'm going to have to use a graph and then synthetic division. Okay? So I'm going to use a graph and synthetic division, and then that's going to actually help me solve. I tried factoring first because that's quick and easy, but it didn't work, so I got to go to this other method. So when I graph this guy, I actually have a cubic function, but notice it only crosses the x-axis once. So now I'm thinking, is it a triple root? So do I hit -1 3 times? Do I have some imaginary solutions? What are the other things that I'm going to get from here? So I know -1, so I'm going to write this over to the side. I know one of my zeros is -1, so now I'm going to perform the synthetic division process, and I'm going to see what else I get. So as I go through this, so this is synthetic division. If you need to rewatch a video on that, you can go to the previous section and do so. I'm left with this x squared plus 3x plus 3. So what two numbers multiply to the constant right here that adds the middle term? There's no combination. So I actually need to use the quadratic formula. So oh my gosh, a graph, synthetic division, and then I got to go to the quadratic formula in order to solve. So I have -b plus or minus the square root of b squared minus 4 times a times c all over 2a, which is 1. So let me erase this. And I'm going to go ahead and simplify that. So I have -3 plus or minus the square root of 9 minus 12. And I'm already seeing here underneath the radical, the 9 minus 12 is going to give me a negative number. So we have -3 plus or minus the square root of -3 all over 2. Well, how do I work with that guy? Oops. And so now I'm going to have my other guy. I'll put it over here, but I'm going to actually work with this and simplify it. I have a -3 plus or minus I root 3 all over 2. So that is my other solution. Now it's a 0, and so if I took this, what's in blue, if I took this guy and plugged it in for x, the algebra might be a pain because of I in the radical, but would end up giving me 0 as a result. So I do have 3 solutions here. 2 of them are imaginary, and 1 is real. And so we're going to go ahead and see here is that when I have a imaginary solution, they're always going to work in pairs. And so if you notice, in the previous problem, I had negative 3 plus or minus I root 3 all over 2. So if we split it up, it is the exact same numerical values except for these guys right here. And these are called conjugates. Okay? And imaginary solutions will always come in pairs of conjugates. We'll have a plus and a minus. And those are always going to happen when we have an imaginary solution. And they always come in pairs. Okay? So, if I have a cubic function and I have one real solution and one imaginary solution, and that's all I'm telling you, there has to be one more imaginary. And this gives me my 3 total solutions. Okay? Real numbers can be individuals, but imaginary solutions have to come in pairs. So another example is if I have a cubic function. If I have 2 real solutions, my other solution has to be real. Reason is, if it was imaginary, I'd have to have 2 of them. Cubic function only has 3 solutions. So that means the 2 real plus 1 more real is going to equal 3 solutions. So that works. But if I had 2 real, I would have to have 2 imaginary because they come in pairs. That would be 4 solutions. That doesn't work for a cubic function. So imaginary solutions always come in pairs. So we've applied the ideas that we've talked about in sections 7.4 and 7.3 with synthetic division. But now we have these theorems about our solutions with polynomials that we're now starting to work with and talk about with each problem.